So I'm involved also together with Ugis and Barry in the Risk Hunter project, and today I want to talk about knowledge graphs and share some ideas how we want to leverage knowledge graphs in the Risk Hunter project. So it's more a high-level session, not too technical. So I will explain what knowledge graphs are, why we should use them, and which are the first steps we should take. So I have here a very simple explanation. A knowledge graph consists of knowledge and a graph database. So knowledge informed from representations, typically in the form of subject, object, predicate. For example, Charles is the king, and in form of a graph database. So, and here the clue is that it is not a SQL database, so not in form of tables, but it's a graph representation. And one of the famous graph databases we all used is Facebook. So they represent, for example, the knowledge Peter knows Mary, and they have built their whole business model on representing these representations. And a more formal explanation would be that a knowledge graph is a structural representation of a knowledge domain, and it should be used by humans as well as machines. So this means it's could be on one way important also for further activities in machine learnings. On the other hand, it is useful to users and could improve search as well, the knowledge management within projects or distributed organizations. And currently one of the famous and most discussed knowledge graph is the COVIDGRAPH. So it is a knowledge graph that captures information from different sources and builds the relation. So this means that the knowledge graph maybe contains copies of the metadata of these objects. It's not the idea that the knowledge graph should replace any existing databases. It is, so to say, on a level above, and should enable also a federated search. With this COVID knowledge graph, you would be supported if you are a researcher, and for example, if you want to get the latest research from PubMed about the COVID research, or if you want to connect to any clinical trials or statistics from for COVID data. And also, if we look at the commercial side, all the top 10 companies, Google, Amazon, Netflix, Facebook, they all use knowledge graph technology. So also the idea of the Google search depends on some graph algorithms. Netflix also tries to map your preferences and the content of the films in its knowledge graph. So it's also very important now that also research institutions and product development companies can use this technology. So one important goal is the user. So he should be enabled to search and visually explore the relationships. For example, here we have the screenshot of the COVID knowledge graph. And for example, if you want to explore more here, the relationship between a compound or the gene ontology, you can click here and search. On the other side, knowledge graphs can be used by machines, and that would enable a better semantic classifications, especially for machine learning, as the knowledge in the graph was also modeled by human experts. So in comparison to pure machine learning, where you just take the raw data, a knowledge graph would represent the controlled vocabulary, the ontology of this knowledge domain. And in addition, we have some more new algorithms we could use. For example, the importance of a node. And in fact, these graph-based algorithms are also 150 years old. So if you look at routing algorithms, what's the shortest way between Paris and Berlin? And so this is also a classical graph-based algorithm. And this means that we have the knowledge graph here, for example, from the COVID graph, and we can run graph algorithms based in special languages here. So what's now the benefit? On one side, we have the users. We want to improve search and combine internal as well as external data sources. We could build up a knowledge base for artificial intelligence. We can try to improve our data management within the organization. And we could also try to improve the knowledge management within a network of organizations, for example, like a EU project like Risk Hunter. And if we think, how can we do this? On one side, we have to say, okay, knowledge is represented in documents, dossiers, in mails, in databases, also in the relationships, who is expert for this topic, and also for lessons learned projects. So one stream of activities is to think, how can we leverage knowledge graphs for the classical knowledge management use cases that we have? And there we are taking the first steps in Risk Hunter. The other typical question is, how can we improve search and combine internal, external data sources? And also, as Uge said, there are a lot of databases. So on one side, we have to select which data sources do we want to connect as well. How do we store our data during the project, and how can we combine the internal and external data? And if we come to the topic of machine learning, it's a question, how can we improve the results? On one side, we are more in this area of text-based mining. So to say, we have a knowledge domain, we represent it in a format like RDF, and the machine learning algorithms can query this knowledge base to improve their results. On the other side, we can look for graph algorithms and do some calculation. So these algorithms are currently more in the banking area if we have fraud detection, but they could be also used in research projects. And this topic is also a little bit called machine teaching. So to teach the machine learning infrastructure with the knowledge domain. And the last field of use cases is around the data management. On one side, we want to improve the trust in the data. So we want to have immutable data. We want to have data lineage. And there are some new standards also to have a structured data catalog or a data governance. So we are exploring also how can we use the DCAT format to better represent the relationship between the files of a research project, the articles, and then the submissions. And on one side, it's important to have a mapping for the metadata in such data catalog if we want to think about interoperability. So here are some few questions. For example, if you want to brainstorm, how can we leverage knowledge graphs for our project? So on one side, important is which standard for terminologies do you use, and are these terminologies in a machine-readable form represented, like RDF, or do you have to take the effort to do your own vocabulary and represent it, for example, in a knowledge graph? Then the next question is, which internal and external data sources should be connected? How would you enable the data management and ensure data quality? And maybe also, how do you connect to internal and external experts? So it's as we are in this topic of knowledge management, it's not only the data, it's about also the knowledge of experts. And the last field and question would be, how can we enhance the data management and the text mining, for example, with knowledge graphs? Are there, for example, terms that you have to identify, or phrases that have to be clustered, and then you can better improve this? And a lot of research has also been done with text mining around health documents and health records. And I think there the experience is, if you provide a knowledge graph or vocabulary, then you can improve the results. So this was the first step for introduction into knowledge graphs. And if you want to have more information, on one side, on LinkedIn Learning, I have a e-learning. It's called Data Science Foundation Knowledge Graphs. So 6,000 participants already have taken this course. And on the other side, we are always happy at Edelweiss Connect to discuss potential new applications of knowledge graphs with you. And we will also keep you informed about our progress in the Risk Hunter project.